handy for me to check. Oh, I'll turn this a little bit more to the left, maybe it'll help you. There we go. And it's still too bright in here.
I told you, give it a kick.
A little better. Okay. What was I? Surds, yeah. So the last time we were having a look at surds, so this time we're going to have a look at complete the square. This is something which I find some students do in middle school and some don't do at middle school. So just before we start, let's take a simple example to get us thinking about this. X plus 1 squared plus 2. Well, maybe I could even go back a step further. I don't remember, we'll go to that in a second. Don't remember if I gave you the name for this, but I'm sure some people know the name already. What type of equation is this called? It's called the quadratic, yeah. Quadratic equation. Usually, not always, but usually it's equal to 0. And I can call it quadratic as long as a is not 0. Because then if a is 0, what would it become? If a was 0. It'd be linear then if a was 0 then. Okay, so just a is not 0. So for example, 2x squared plus 3x plus 1 equals 0. I probably gave you the name when we were doing factorizing, right? Did we do factorizing or we didn't do that yet? No, we did factorizing, yeah. So that's quadratic. Now, what I want everybody to do for me is to simplify this. Okay, so just expand and simplify. It should only take you like 20 seconds at most. Let's have a look. Yeah, that's good. Yeah. Got it, yeah? Yeah, well, let's look at it now. So, there's a quick way to expand this. Now, there's two ways. Some students like to write this down and then do it out like this, and that's fine, but because you do these so often, it's good to remember the quick way to do it. So the quick way is, it's the first squared, then twice the first multiply the second. So this is 2 times x times 1, which is 2x. And then finally, it's the second one squared. So 1 squared is 1 plus 2. So in total, we have x squared plus 2x plus 3.
But this method is usually used for cubic.
No, quadratic or cubic, yeah. You mean, yeah, with a cubic, then there's a triple in the middle, yeah. And we will look at those too as well, but for the moment, it's just quadratic. So let's just do another one really quick. X plus 2 squared plus 3. So that would be x squared plus, what would be next? 4x plus 4 plus 3. So this is x squared plus 4x plus 7. So we know that writing it this way is called, what's the verb? Oh, thank you, expand. Going backwards is not factorizing, okay? Because factorizing is when we write it with 2, like this.
No, we can't.
So it's not factor. We can maybe find the factors. This is complete. This is what completing the square means. So this is vocabulary you must know for the exam. So completing the square is going backwards to this form. And expand we already know. So this is actually the name of the lesson. So what we'll learn today is how to go from this result back to this. That's what we're going to learn. So if you can at least write the title down. And I'll often write it shorthand as just this, completing the square. Okay. So the reason we complete the square, there's a few reasons. Number one, it can help us to solve the equation. Number two, it can help us to draw the equation. And number three, we can use it to prove things as well. So let's have a look at how we can complete the square. I'll pick an example here. Okay, can I scroll down? Yeah. Alright, so let's take something like x squared plus 6x plus 18. So the method I'm going to show you works as long as there's a 1 in the front here. More like a technique rather than a formula. So as long as you have a 1 here, then what I'm about to show you will work. And then I'll show you what to do when it's not a 1. By the way, does anyone know the adjective I should put in front of quadratic that means there's a 1 in the front of it? What'd you say? You are exactly right. And that's actually surprising because nobody gets it. So congratulations to you. Monic quadratic, meaning like 1. Mono is 1. So there's the lead is 1. Okay. Right. How do we complete the square for a monic quadratic? It's actually quite easy to do. First, you take the number in the middle and half it. So you get x plus 3 squared. You write it like this, sorry, and I should actually really have said what we're trying to get. We're trying to get x plus a number squared plus another number. So we're looking for these two numbers. So this one is super easy to get. It's just half of that. So positive 6 will be positive 3. The next one is just a little bit more difficult, but not very difficult. So what you do is, it's 18 minus 3 squared. Yeah. So I'll just say that again. It's 18, because we use this number, minus, and it's always minus. Doesn't matter what it is, it's always minus. This number squared. 3 squared. So that leaves us with 9 here. And you can check that this works if you want. So if we were to do a quick check here, we get x squared plus 6x plus 9 plus 9, which is what we had to begin with. So it does work if you were to check it. So I'll do another example, and then I'll do something a little bit more difficult when there's a number in the front and maybe if there's a minus or something. But this is your first example, so if you can write that down. You don't need to check it, of course. In the exam, unless you had lots of time left, you shouldn't be checking it. It's not difficult to get, not difficult to do. You shouldn't get it wrong. The only thing you need to be careful about is here it's always minus. And here it's half of this number, and don't forget if there was a minus here, there'll be a minus here. Okay? Yeah?
It's minus 3. It's going to be minus 3.
If there was a minus here, then there'll be a minus here. Because it's half of positive 6 or negative 6 goes here. And this is always a minus. It doesn't matter what these numbers are, it's always a minus for this part. Always. So this positive 18 minus 3 squared. Yeah?
How did you get that 9?
Which one here?
No, 18 minus that number.
This part, is it? Yeah. This is the method. What you do is you take the number at the end, and then you minus the number you got previously squared. I'll do another example to show you. So let's take another example. Let's say x squared plus 10x plus 26. So straight away I can see it must be x plus 5. So that's fine, that part. And then the number at the back is 26 minus 5 squared. 26 minus 5 squared is 1. Yeah. Okay. Now, I'll just give you one to try before moving on to something more difficult. So, just to make sure you've got it, just quickly write down the answer for this one. X squared plus 2x plus 9, for example. The one, sorry, I should write it down here. The one was 26 minus 25. Yeah?
2x?
2x. we get x plus 1 squared, and then 9 minus 1 squared is 8.
Pretty easy.
More than pretty easy, very easy. Yeah. Now, let's do one that's just a little bit more difficult. I'll let you try it. It's only difficult because you might have to use your calculator, that's all. So just try this one for me. X squared minus 5x minus 3 over 4.
Can I use the
Yeah, please do, actually. Okay. This monitor is the problem, isn't it? Yeah, well, we'll do it now. I don't think it should take you too long. So, with the calculators especially, you should be able to do it quick. Straight away I can see it's x minus 5 over 2, yeah, squared. And then at the back,
minus 1.75.
yeah, it'll be minus 3 over 4, yeah.
Why didn't write half 1 over 2? Half the 5.
Yeah, 5 over 2. You can leave it like that, yeah.
I can't write 2
Oh, yes. Yes, yes, you can. It's fine, yeah. Minus 3 over 4 minus 25 over 4. This squared. Hmm? Oh, no, I see it. No. You weren't listening to me earlier, or you forgot. I said, no, listen. Listen, please, listen. I said, it's this number minus, always minus the square of this number. Now, the minus here doesn't matter, because when you square, it becomes positive. Yeah, so there's no minus here. It's this number minus this number squared. And even if you included the minus, it doesn't matter, because when you square it, it's gone. So it should be minus 3 over 4, minus 25 over 4. What's that, minus 28 over 4, minus 7? Is it? Minus 7, yeah. So minus 7 goes at the back. Yeah. Okay. The only problem with that is using the calculator. I'll move on now from that. Now what to do if it's not monic. Okay. Can I scroll down? Yeah. Did I hear one no?
Yes.
It's okay? Moving on anyways. Now, what to do if it's not monic? So if it's something like 7x squared minus 70x plus 183. Yeah, not quite divide. Yeah, what's the other verb? Not quite divide, although it is divide, and it's another verb. Factor out. Yeah. So we factor out the 7. So here we'll get 7 factored out. So the first one becomes x squared minus 10x plus 183 over 7. So now what you have is just a problem like before. It's just a normal problem. And you can worry about the 7 later. So this will be 7 x minus 5, yeah?
Why is 183 divided by 7?
Each of these you divide by 7.
Okay.
I don't think this simplifies. Does it? I don't think it does. It shouldn't. It doesn't. Yeah. So x minus 5 squared, and then at the back you have 183 over 7 minus 25. Yeah, and we should get 8 over 7? Now there's one step left. What's that? Multiply in the 7, yeah. So we get 7 x minus 5 squared plus 8. Yeah. Now this makes sense because if you think about it, at the very beginning, here's the question. Is there any fractions here? Any fractions like p over q, fractions? No. They're all whole numbers. 7, 70, 183. No fractions. So it makes sense that when we get to the end, we shouldn't have fractions as well. So we only have fractions in the middle for our work, but at the end, no fractions, like at the start.
What's fraction for the start?
He probably made a mistake. If there was at the start?
Yeah.
Oh, that doesn't matter. Then there could be fractions at the end. Yeah. Okay. Let's see. Maybe we'll continue with this example then. Yeah.
Actually, I didn't understand this.
I'll do another one of these. Yeah. Okay, can I scroll down?
Yes.
Yeah. Right. What I'll do is I'll let you try for a minute, then I'll do it. So we'll put a minus in the front, not that it matters.
Is that 90?
Minus 9x squared minus 90x minus 219. Complete the square. Okay, nearly finished? Okay, let's have a look at it, yeah. So what should I do first? Factor out the minus 9. So I have minus 9 bracket x squared plus 10x plus 219 over 9. So that would be minus 9 x plus 5 squared again, and then 219 over 9 minus 25, which is minus 2 over 3. And then we finish by multiplying both of these by minus 9. So we get minus 9 x plus 5 squared plus 6. Yeah. Okay. Right. Next now, when you have that taken down, we'll look at what we can do with this answer. Okay, so there's some things we can now do with this that we couldn't do with this one. Okay. Continue? Yep. Okay, so what is the application here? So let's take an example. Let's say I have something like y equals 6x squared plus 60x plus 155. Let's complete the square. Actually, you know what? Maybe I'll make it easier for the first one. I'll take out the... Maybe I'll just... No, I think... I believe in you. We'll leave the 6 in there. So we get y equals 6 bracket x squared plus 10x plus 155 over 6. That equals 6 bracket x plus 5 squared plus, and then we have 155 over 6 minus 25. You have it? 5 over 6. So that's nice. We then just finish by multiplying by 6, and we get 6 bracket x plus 5 squared plus 5. And this is what the y equals. Okay. So, if I just... I'll leave it there. If you were just to pick some random numbers for x, so for example, if x equals 0, you put that in, you get a value for y. If x equals 1, you put that in, you get a value for y, and so on. If you look at this carefully, you might see this what the smallest value of y should be. So there is an answer that you'll get for y, and it's the smallest answer you can get, and you can't get less than that. No, I can't get 0 here. 5. And the reason for that is, if you look very carefully at this, it's made of two parts, of course. The first part is the 5 at the back, and the second part is this square piece. Now, because this is squared, you know it must be positive. It cannot be negative because of the square. The least it can be is actually 0. And when could that be 0? For what values of x would make this piece 0? No, because if you put in 0, you don't get 0. Minus 5 would make that 0, wouldn't it? So if you have 5 plus something which is always positive and is at least 0, then the total here, you know, must be at least 5. It can't be less than 5. It's impossible. If it was less than 5, it meant that this piece was negative, which is impossible. So you can see that y, the minimum value it can be is 5, and this happens when x is, not when x is there, when this part is 0, which is when x is minus 5 to make this 0. So this point minus 5, 5 is the lowest, it's the minimum point. Now we haven't done the graphs yet, and we will do the graphs in another lesson. But for the people who've seen this graph before, what I'm saying is that point is this one here. It's the minimum point. But don't worry, we'll have a different lesson on that. So this is called the minimum point, is one name for it. Does anyone know another name for it? Turning point, yeah. Vertex, very good, yeah. Minimum point, turning point, or vertex.
So in the exam, you'll ask us to find the vertex or turning point minimum?
Yeah, it could be one of these words, yeah. Minimum point, turning point, or vertex. And there's other words too, which we'll get to as well.
Did you do now, please?
Yeah. I'll do another example of this, okay? Now, it's not always a minimum point. Sometimes it could be a maximum point. Or vertex, yeah. When it looks like this. I think I'll do that one next. So just write this one down, please. So this is one use of completing the square. You can use it to find minimum points, least values. Yes, is this okay? Yeah? Do I have everyone?
No.
Almost.
Probably everyone.
Almost/probably everyone. I'll have to check in a minute. Okay, can I scroll down?
Wait.
Are we just waiting for you? Then we are continuing. Okay, let's have a look at another example. So let's say minus 9x squared minus 144x minus 577. I would like everyone to complete the square for this one, okay? So if you can all complete the square for this. Okay, yeah. So who has the completed square here? You have it up here, yeah?
Minus 9.
Yeah, bracket x,
X plus 8 the whole square.
Yeah.
Minus
minus 1.
minus.
Like this? Yeah, great. I'll just rewrite that a little bit for this one. I'll just write it as y equals minus 1 minus 9 x plus 8 squared. And I want you to focus on these two parts. So this is the first part, this is the second part, and then we have our minus in the middle here. So if you think about what's happening here, you have a number minus something which is always positive, a square. So if you have a number minus something which is positive, does your answer get bigger or smaller? It gets smaller, of course. So if you want to make this as big as possible, then you should minus nothing. Yeah, you should minus 0. You know, if I have 5 minus 1 or 5 minus 2, I'm making it smaller. If I want to make it a maximum, I should minus nothing, minus 0. So how can I make this 0? Again, like last time, you should use x as minus 8. And then will this be a maximum value or a minimum value? Maximum. Maximum. So now we get y maximum is minus 1. And when does this happen? When x equals... Not again. No. Minus 8. Minus 8, yes. So the turning point is minus 8 minus 1. But this time, it's a maximum. Yeah. But I hope what you can see is it doesn't matter if it's minimum or maximum. It's the same as before. So if you have y equals a x plus b squared plus c, where's the turning point? The turning point is at minus b comma c. It's always this for the y and always the minus of this for the x. Okay, so it doesn't matter if it's minimum or maximum, you do it the same way for both. Yeah.
I understand the x, I understood the c for the y, but what do you mean by minus b?
Here, this is the x.
Oh,
So
yeah.
the x is minus b.
Okay, I understand.
So like here, yeah, if it's x plus 8, then you should use minus 8. Yeah, it's okay. Focus now. Can I scroll down? Well, there's 2 more examples I want to show you then.
Scroll down.
Yes? Okay. Say again?
X plus 8, can it ever be x minus 8?
It can be, yeah, x plus 8 minus 8, whatever, it doesn't matter. When it's squared, whatever it is, it becomes positive. So, yeah, here you can get, have all my examples been a plus number here? Oh, that's just an accident. You can get minus 8, and then that would mean you should use plus 8, yeah. That's the first time that's ever happened. Yes, you can get plus or minus. Okay, let's do the next example. So if you can write this down. Find B and C if y equals minus x squared plus bx plus c has, number 1, a turning point at x equals 6, and number 2, a y-intercept at y equals minus 42. Write this down, please, and then I'll do it now. So what's happening here is you have a quadratic, but there are 2 coefficients missing. You don't know the b and you don't know the c. So there's 2 pieces of information missing. And what we're going to do is find the b and c using this information that's given. You're told that the turning point happens when x is 6, and you're also told that the y-intercept is minus 42. So which would be the easier one to use first, the turning point or the intercept? What do you think? The intercept, yeah, because what can the intercept give you pretty quickly? It can give you the c. Yeah. If you know that it crosses the y-axis as minus 42, you know that the c must be minus 42, because you want minus 42 when the x is 0. So y equals minus x squared plus bx minus 42. When x is 0, you want minus 42. That's the y-intercept. So we've already used this piece of information. Now we need to use this piece to get the b. Okay? So we know that the turning point is at 6. So what we do is we try to find the turning point. Question? Yeah, but we have no way of finding the gradient yet.
Could you use the point minus 42 0, minus 42?
Oh, it's 1 point?
Yeah.
And the other point will be... Yes. So, you're true, the gradient is 0 at the turning point, but as of yet, that's not enough to work it out. It will be later, though. Right, so let's find the turning point as normal by completing the square. So first I need to factor out... what? The minus 1, yeah. So we're left with x squared minus bx plus 42. I'll zoom out rather than scrolling down. So I have y equals minus 1 bracket, and what do I have here? X minus b over 2 squared, and then plus, possibly, some stuff I don't care about. Now the reason why I don't care about it, you'll see in a moment, but I don't actually care about the rest here, because I have enough now. I know that the turning point happens when x is 6. I also know from looking at this, the turning point happens when x should be equal to b over 2. So if I look at this, I know, okay, this is where the turning point should be. But I also am told the turning point should be when x is 6. So if I put these two things together, therefore b over 2 should equal 6. So what's the b? 12. So now I found the b. Yeah, so it's by making a comparison. I know by this the turning point happens when x is b over 2, and I'm told that that happens at 6, so therefore b over 2 must be 6, b is 12. Now this is getting a bit more complicated, but I have seen this on the exam, that's why it's in the book, okay? Every page in this book was made by me, every question was made by me, and it's all exam focused. So if it's in the book, it could be on the exam. This doesn't happen often, but I've seen it twice on the exam, okay? And it is a more difficult one. So if you write that down, we'll do one more example. So please write this one down carefully. Yes.
Stuff that you said you don't really need.
Yep.
What was the other stuff that you said?
The other stuff which I don't really need. This was 42 minus b squared over 4.
Why 4?
This squared.
Yeah, alright.
So again, you like to go this way.
Then why did you divide by 2?
This is the completing the square process. You half the middle number.
So now
the number is...
The middle number was b, so here it's b over 2.
Yeah, why did you divide it by 2?
Why?
Yeah.
I do not understand your question. In every complete the square example I have, I always divide the middle number by 2.
Why?
Well, that's what I've done the last 8 times. Why didn't you ask me the other 8 times? Why did you wait for the most difficult one to ask me? Come in!
The door.
Yeah, sorry. The door's a bit stiff. Can I just do one example really quickly then? I think everyone's here. I have the class list anyways. Okay, have we got this? Well, if not, you'll have to get it from the video. I'll just run through the last example now. Okay, last example then. 3x squared minus 54x plus 250. Okay, so for this one, no matter what value of x you can pick, if you put it into this quadratic, the result will always be positive. So for example, if you put x is 0, what do you get here? 250. And if you put x is 1, no, if x is 1, well, you don't have to work it out, but would it be positive? Yeah, it would be. 250 plus 3 minus 54, positive. In fact, no matter what value of x you pick, this is always going to be positive. And what we're going to do is prove that it's always going to be positive, okay? And we'll do that by completing the square. So firstly, what do I factor out? 3. X squared minus, what's next here? Let's see, 118, is it? X plus 250 over 3. Next, x 9 squared, and then at the back is 250 over 3 minus what? Very good. So that leaves me with 7 over 3 at the back, and then we multiply by 3. Now somebody tell me, why has this proven that it's always positive? Yeah. Well, this is positive because it's a square. And this is positive because it's positive 7. And when you add two positive numbers together, it's always positive. Yeah. So we've proven that this quadratic is always positive. Someone will ask me in a minute now, well, what happens if this is a minus? I see there's always one person thinking that, and the answer is you've done something wrong in your proof then. So you should end up with two positives here. That's fine if it's a minus here. No, well, this was a minus here. Yeah, so it's okay. You only care that at the end you get two positive numbers. You've proven that this is always positive because it can be rewritten as two positive numbers added together. If this is minus, it doesn't matter as long as you get positive and positive at the end. Yeah.
What if it's, oh, so 250, okay, so
Yeah. Yeah, I think we've done all the possibilities. Okay, so just, Colina wants to talk to you for a minute, so just I'll give you the homework. No, I think we'll do an A-B today. We'll do... No. We'll just do ABC. ABC. From each one, yeah. Yes. Oh yeah, you need a Moodle account, and I'll talk to you in a few minutes then. Okay, A, B, C in each question, up the front. Hey. Which questions?